this. I'm sure not even in your wildest dreams you would have tried to solve this equation other than with a calculator. And you can say, but we are still using a calculator. Yes, because the numbers are difficult to calculate, to work with, right? But now you know how to solve even something like this. How? Going through these steps. Identifying that the function is continuous, finding an interval based on the intermediate value theorem for continuous functions, using Newton's method, yes, plugging it in the calculator, starting with an initial value, or if you want to call it x1, fine, and then finding as many iterations as you need till you stop for whatever number of digits. Okay, now please let me know if you need to work on another problem, another equation, and we will.
Yes, and I have several questions.
Yes, I'm ready.
How do you know when to stop in the iterations?
Because I'm told 6, and they already repeated. Those 6 already repeated.
Oh, that's how you tell. Okay. Second thing, when you started doing stuff in the calculator.
Yes.
You were going really fast, and I couldn't.
Oh, yeah. Let's do it again. Let's do it again.
I completely missed all of that.
So you know how to enter this in the calculator, right?
Yeah, the y equals. I know how to do that.
Okay, so let's do that again because I deleted it, I have to go back in there and put it again. So we have x minus quantity. Okay, left parenthesis, and then cosine x minus 1. Okay, we can get more decimal digits with Newton's method than with a 0, though, I think. Okay, so after you have this, you get out of that window with second and quit. And then you go to variables, and you're interested in the y variables because that's where the variable is, the function if you want, right? In y1, I have Newton's function. So I'll press enter, and no, I didn't mean that. Sorry. So I go to y variables, I choose the function, I press enter, and I'm using y1. So in y1, I decided to start with 2, and I press enter. And this is the first iteration. So my 2 is x0, and this is my x1. So let's stop here for 1 second. So this is what we did. So in order to determine x1, I had x, which was 2, minus f of 2 over f prime of 2. All this, the calculator calculated this and gave me this number, 1.935951152.
You did something that let you.
Oh, I didn't finish. No, I didn't finish. I was just explaining the first iteration.
No, that's in the calculator when you were putting something into the y equals thing. You did something where you could insert things out over.
Oh, I didn't get to that. I'm just doing it one more time slower. Yes, I will not forget. I did not get to that. Just 1 second. So this is what we did, what the calculator did for us. So entered 2 here, f of 2 and f prime of 2, calculated this and got this. Now, I want to go back in the same function, but this time I want the calculator. I don't want to type this number in. I want the calculator to take it and put it here, minus f of this number x1 over f prime of x1. And calculator will do that. Here's how. I do second and entry. And with second and entry, the calculator copies this. But I already calculated this. I want the calculator to take this number and put it in. So I will have to highlight 2 or overwrite 2. Once the cursor is on 2, I go to second and minus the previous answer. The previous answer being this number. I need to do this just one time, because then I copy the whole thing and I press again. I copy the whole thing and I enter again. I no longer have to overwrite anything, because now the calculator in the next step will use this number in here. In the next step will use this number in here. In the next step we'll use this number in here. So if you want 2, 4, 6, 9 digits, you can have them already from the third iteration. So you don't need the last 2 anymore. Is this okay? Anything else? Other questions on this? So one more time, do we need another problem? If the answer is no, then we look at optimization. If the answer is yes, we'll choose another.
I wouldn't mind doing another one.
Of course. Would you like to choose, or you want me to choose?
It's your choice, ma'am.
Okay, so I'm looking at 27. It looks weird. 27, the square root of 4 minus x squared. No, it's not x squared, it's x cubed. Okay, equals e to x squared. I have no idea where we're going with this, but we'll see.
One last thing on the previous problem.
Say it again.
The x base 0, I forgot what that's called. How do we get that to be 2?
We found an interval based on the intermediate value theorem. We found an interval where the function changes sign because it's a continuous function. If it's a continuous function and changes sign, it must have a number between, there must be a number between 1 and 2, and we did find it, 1.934563, such that f of c is 0.
So you just use the later number in the
You
interval?
you can start with x equals 1, you can start with x equals 2, you can start with x equals 1.5, you can start with x equals 1.7, whatever you want. I chose 2. Is that okay?
Yeah.
Other questions before we start this one?
Yeah, so if we start with any number, is it going to give us the same solution?
Oh, absolutely. There is only one.
Okay.
Absolutely. There is only one solution. You saw the graph. Yep. You can start at 2. I start at 2. You can start at 1. And Sean starts at 1.5. And we will all get the same answer. There is
But
only...
when you say start at any number, you do mean the numbers on the interval, correct?
Yes, between 1 and 2. Either at 1 or at 1.5 or 1.7 or 2. Yes. Because that's where we checked. We checked at the interval, and we have to have a 1 unit interval. We checked that f of 1 is positive and f of 2 is negative. By the intermediate value theorem, there exists a number such that f of c is 0 between those two. You can look at the graph and say, oh, but I can start at 10. No, you shouldn't. It will take you possibly forever. You should start with a 1 unit interval where the solution exists. Is this okay? Other questions? Okay, so our first step is creating the function. So 4 minus x cubed minus e to x squared equals 0. So our function is weird. Okay. So in step 2, I will plug in the function and try to find an interval. Now I have to be careful because 4 minus x cubed has to be greater than or equal to 0. I cannot start anywhere I want, right? So x cubed has to be a number less than 4, or x has to be a number less than or equal to the cube root of 4. So I'm looking at the negative. So don't start plugging in 10 because you're going to get an error. So always remember domain, 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 domain. Okay, so I start with the square root of 4 minus x cubed. Okay. And then minus e raised to x squared. Okay. So second and table. Oh, how beautiful. So a negative 1 is negative, at 0 is positive. Yay! So this f of x is continuous, at least on negative 1, 0. You can find the other one from 0 to 1. It doesn't matter to me, whichever. It's not important. Okay? Because I see there is one here between negative 1 and 0, and there is also another one from 0 to 1. Doesn't matter. Okay? F of x is continuous on negative 1, 0. F of negative 1. So the negative 1 was, again, yes, negative and then positive. Good. So negative and positive. By IVT, there exists a C in the open interval, negative 1, 0, such that f of C is 0. Good. So now I create the function that I call Newton's function, x minus the function, awful, 4 minus x cubed minus e to x squared divided by its derivative. Yes, there is a way of punching in the derivative. That's fine too. So 1 over 2, the square root of 4 minus x cubed, and then negative 3x squared, and minus e to x squared times 2x. Be very careful because 0 will not work. Look here what happens. If you try to start at 0, it will be a tragedy. This piece is 0, this piece is 0. You will not be able to. So if I use this, I have to start with my initial value as being negative 1. Okay, so back to put in the function. Don't erase anything. So second and in x minus parentheses for all the numerator. Okay, divided by parentheses for the denominator. And this is awful to enter. Be very careful. Negative 3x squared. And divided by, in parentheses, 2 the square root, because otherwise you will only divide by the square by 2 and not the square root. 4 minus x cubed. Close the parenthesis. And this is the parenthesis inside the square root. And now I need the parenthesis outside of the square root. And then minus 2x and e to x squared. And don't forget to put the parenthesis for the entire denominator now. So the entire denominator is this negative 3x squared divided by this and minus 2x e to x squared. Okay, so get out of there after you, are we already there? Do we have the function in? Do we need more time to put the function in?
Yes.
Okay. A sip of water for me. Let me know. Is it okay? Should I still wait?
I got it in.
Everyone? Yes? So now we exit. We go to variables. We want the y variable. We click on the function. We want function y1. We want to plug in -1. And this is our x1 right now. This is it, x1. First iteration, -0.89881666537. And now this is just one time. Second an entry, just one time. Override -1 with this. Second an answer. Make sure you eliminate that 1. So it looks like y1 of the answer, which is this. And then you just repeat. That's it. Repeat. Okay, so x sub 2. So we still want, what did they say on this problem? To find all solutions correct to 8 decimal places on this one. Okay, fine. So I have my x1, my x2, -0.8789133396. Okay, x3, -0.878283525. And then x sub 4, -0.87828292223. Do I have, I have already 5 digits. Okay, I have to repeat. Okay, I have them all now. This is it. I don't have to write the last one because they're all the same now. So therefore, it converged in 4 iterations, and for 8 digits, I get this. Any questions?
Could I see your y equals one more time? I was getting a different answer.
So, oops, I didn't mean that. Okay, so it's x minus what we had. This is the function. So I think potentially the error is only in the denominator with the derivative.
Yeah, I didn't put parentheses around x squared, so I see.
Well, I'm overdoing it with parentheses, but I trust myself more than the calculator. So the denominator has to have the small minus, not the operational minus.